You are holding something in your hand right now. A phone. A cup. Maybe nothing at all, just your own fingers. It feels ordinary. But the real answer is far stranger, because the iron in your blood was forged in the collapsing core of a star that died before the sun existed. Not metaphorically. Literally. Every atom heavier than helium inside your body was manufactured in a place hotter than anything you can imagine, then thrown across space, then folded into a rock, then into water, then into a plant, then into you. You are the ash of something enormous. And the strangest part is how recently anyone figured that out. Start with what you are made of. Roughly 65% of your mass is oxygen. About 18% is carbon. 10% hydrogen. 3% nitrogen. Then a thin scattering of calcium in your bones, phosphorus in your DNA, iron in your blood, potassium sparking across your nerves right now as you listen. 6 elements do almost all the work of keeping you alive. Where did they come from? For most of human history, that question had no answer that made sense. Fire was a substance. Air was an element. The stars were lights, or holes in a sphere, or gods. Nobody imagined the stars were factories, because nobody knew what stars were made of. That answer arrived in 1925, and it arrived from a 25-year-old woman named Cecilia Payne. She was working at Harvard, analyzing the light of stars. When you spread starlight out into a rainbow, dark lines appear in it. Each line is a fingerprint. Each element absorbs light at its own specific colors, so the pattern of missing colors tells you what the star is built from. Payne worked through those fingerprints with a rigor nobody had applied before. Her conclusion was almost absurd at the time. Stars were not made of the same stuff as Earth. Stars were overwhelmingly hydrogen and helium. The lightest, simplest things that exist. Her advisor pressured her to soften the claim. She wrote in her thesis that the result was probably not real. It was real. Within a few years everyone agreed, and the astronomer Otto Struve later called her thesis the most brilliant ever written in astronomy. So the universe began simple. Hydrogen. Helium. A whisper of lithium. That is nearly the entire ingredient list of the early cosmos. But you are not made of hydrogen and helium. You are made of carbon and oxygen and calcium and iron. Heavy things. Complicated things. So who built them? Here is where it gets physical. A star is a permanent argument between two forces. Gravity pulls every part of it inward, trying to crush it into a point. Heat pushes outward, trying to blow it apart. For most of a star's life, those two forces are perfectly matched, and the star just sits there, glowing, stable, for billions of years. The heat comes from fusion. Deep in the core, where pressure is unthinkable, hydrogen nuclei are slammed together so hard they merge into helium. That merger releases energy. The energy pushes outward. The star holds itself up by continuously destroying its own fuel. In 1939, Hans Bethe worked out the exact chain of reactions that lets a star do this. He described how carbon can act as a kind of catalyst, cycling through a series of nuclear steps that convert hydrogen into helium and release energy at exactly the rate we observe in the sun. He won a Nobel Prize for it. He also, in that same work, explained why the sky is bright at all. But fuel runs out. That is the whole story. When a star exhausts the hydrogen in its core, the outward push weakens. Gravity wins a little. The core contracts. Contraction makes it hotter. And at higher temperatures, a new reaction becomes possible, helium fusing into carbon. Do you see the pattern forming? Each time the star runs out of one fuel, it collapses slightly, heats up, and unlocks a heavier fuel. Helium becomes carbon. Carbon becomes neon and oxygen. Oxygen becomes silicon. Silicon becomes iron. A massive star in its final days is built like an onion, with layers of different elements burning at different depths, each one the ash of the layer above it. The whole periodic table is being assembled inside a single dying object. And then it hits iron. Iron is where the machine breaks. Fusing lighter elements releases energy. Fusing iron consumes it. The moment a star's core becomes iron, it stops producing heat, and the argument that held it up for 10 million years ends in less than a second. The core collapses. It falls inward at a significant fraction of the speed of light. It slams into itself, rebounds, and blows the entire outer body of the star across space in an explosion that can briefly outshine an entire galaxy of 100 billion stars. That is a supernova. And in that instant of unimaginable violence, atoms are bombarded with so many loose neutrons that entirely new heavy elements are built in seconds. This idea, that stars are the origin of the elements, was assembled into a complete theory in 1957 in a paper written by four people: Margaret Burbidge, Geoffrey Burbidge, William Fowler, and Fred Hoyle. Astronomers still call it B2FH, after their initials. It is one of the most important scientific papers of the 20th century, and it laid out, reaction by reaction, how the universe went from hydrogen to everything. Fred Hoyle did something even bolder before that. He reasoned backwards. He knew carbon existed, because he was made of it. But the physics of the time said carbon should be almost impossible to build, because 3 helium nuclei would have to meet in essentially the same instant. So Hoyle predicted that carbon must have a specific, previously unknown energy state that made the reaction far easier than it looked. He was told it was a strange way to do physics. Fowler tested it in the lab anyway. The energy state was exactly where Hoyle said it would be. Think about what that means. A man deduced a hidden property of an atomic nucleus purely from the fact that he existed. Margaret Burbidge, meanwhile, was doing the observational work that anchored all of it, at a time when the largest telescope in the world would not grant observing time to women. She got around it. Her husband was listed as the observer. She ran the telescope. So the chain is complete. Simple universe. Stars form. Stars build heavy elements over millions of years. Stars die and scatter those elements into space. New stars and planets condense out of the enriched debris. Some of that debris becomes rock, and ocean, and cells, and eventually something that can wonder where it came from. But here is the twist, and it is more recent than you would expect. Supernovae cannot explain everything. Gold, in particular, was a problem. The theory struggled to produce enough of it. So where does gold come from? On the 17th of August, 2017, detectors in the United States and Italy felt a ripple pass through the shape of space itself. It was the collision of 2 neutron stars, which are the leftover cores of dead stars, city-sized objects so dense that a spoonful of one would weigh as much as a mountain. Telescopes around the world swung toward the glow that followed. In that glow, astronomers saw the signature of freshly manufactured heavy elements, including gold and platinum, in quantities measured in planetary masses. 2 corpses of stars collided, and jewelry was created. The ring on someone's finger is older than the Earth and was born in the most extreme collision the universe permits. Does that change how it looks to you? Now come back to your own body, because this is where it stops being astronomy and becomes personal. The calcium in your teeth was fused inside a star. The oxygen filling your lungs at this exact moment was made in a stellar core. The nitrogen in every strand of your DNA was cooked in a star that died and threw itself outward so that its material could drift for millions of years, and cool, and gather, and eventually be assembled into you. Your blood is red because of iron. That iron was made in the last hours of a massive star's life, in layers of silicon burning at billions of degrees, and released in the explosion that ended it. You are not living under the stars. You are the stars, cooled down and rearranged. And you are borrowed. Every atom in you was in something else before, and will be in something else after. The carbon in your hand may have been in a fern, in a dinosaur, in a limestone cliff, in the atmosphere, in a wheat field, in a loaf of bread. You did not create a single particle of yourself. You assembled yourself out of the neighborhood. Which raises the question underneath all of this. If none of your atoms are original, and all of them are on loan, what exactly is the thing you call you? It is not the material. The material is transient. Most of the atoms in your body will be swapped out for different ones within a few years. What persists is the pattern. The arrangement. The information that keeps organizing new borrowed atoms into the same shape, the same voice, the same memories. You are not a substance. You are a process running on borrowed matter. The astronomer Carl Sagan put it in a sentence that got repeated so many times it started to sound like decoration. Star stuff. It became a poster, a slogan, something people say without hearing it. But it was never poetry. It was a description of a manufacturing process, worked out with spectrographs and nuclear physics, and a woman at Harvard who was told her correct answer was wrong. So look at your hand again. Look at the skin, the veins, the bones underneath. Every element in it has a birthplace, and none of those birthplaces are here. Each one required a star to live for millions of years and then to die in a way violent enough to fling its interior across the galaxy. That happened. Repeatedly. Long before there was anyone to notice. And the universe kept doing it, and the debris kept gathering, and one particular gathering of it eventually cooled into a planet with oceans, and the oceans made cells, and the cells made you, and now the ash of a dead star is sitting somewhere, in a room, listening to a voice explain where it came from. You are holding something in your hand right now. So is everything else in the universe. It just took 13 billion years and one dying star for a piece of it to finally notice what it was holding.